pH is defined as the negative log of the hydrogen ion concentration. What did that tell you? How many of you like logarithms in math? I had to like them. I had to learn to like them. If you look at the term pH, what we're really talking about is hydrogen ion activity. But the reason it's written as a small p, that's talking about the potential for hydrogen, and hydrogen being an element, it's always in an uppercase. Now, it's expressed in logarithmic terms, not a linear term. So, each pH change is a tenfold change. And remember, in logarithms, you don't add, you multiply by. So, if you have a pH of 4, it's 10 times acidic as a pH of 5. How about a pH of 4 and a pH of 6? How many more times acidic is it? 100. Multiplication. Yeah. Okay, a lot of the older literature talked about a soil being sour, it was acid soil, or it was a sweet, it was a basic or an alkaline. How did they test that before we had pH meters? Like, take a dip of it and put it in your mouth and taste of it. No, do not do that nowadays. Do not, do not, do not. You can use this litmus paper to find out what your pH is. You can buy a pH meter, one of these small ones. It's not much larger than this little remote here, for $45 to $75, an economical range. Always buy at least one bottle of a pH adjuster solution so you can always calibrate that pH on that meter. If you don't calibrate it, you may be getting erroneous figures. And we've run across that even as late as, or as early as last week. So, pH is one of the most important soil chemical reactions that we have. pH has a profound effect on the availability of plant nutrients, but also microbial activity. When the soil pH is real low, the microbes don't want to get out of bed and do their job in breaking organic residues down, in breaking organic matter down to release nutrients. They don't like that situation. So, you adjust your pH upward or downward according to the type plants that you're growing. Here's a pH scale of sorts here, and this starts with nitrogen, phosphorus, potassium. What are those? Major nutrients, okay? Here's your pH of 7. I like to call these toothpicks. As these little bars begin to taper off, what it's telling you at that pH of about 5.5, you're getting less and less nitrogen availability strictly because of the pH. And if you look down here at about 5.2, 5.3, it's pretty well tailed off on you. Phosphorus is a weird duck kind of a nutrient. You do not need your pHs up in this area. If you want phosphorus availability, maximum phosphorus availability, you're looking at a pH of about 6.2 to 6.5. In my slides, I'll show you one that says a little bit different than that, but it's concerning all nutrients, not just necessarily phosphorus. If you look at potassium, sulfur, calcium, magnesium, they follow the same pattern. We get down to the micronutrients, and let's just cue in on iron here. As that soil pH is coming on up, and once you reach in here around 6.7, 6.8, then iron availability decreases, strictly because of the pH. And if that wasn't dramatic enough, let's look at it in this light. You have an extremely acid soil with a pH of 4.5. You need to lime unless you're growing blueberries. Okay? You're getting the use of about 30% of the nitrogen, 23% of the phosphate, and maybe 33% of the potash that's native in the soil, and or that fertilizer that you put out in your garden, lawn, or landscape. So you're needing to lime. So let's bring it on up to a pH of 6. That's a good pH. You're getting the use of about 89% of the nitrogen, 52% of the phosphate, and essentially all of your potash. Unless God gave you that pH of 7, don't lime to that level. There's no need to go there. You can run yourself into more problems with the micronutrients. You will never ever get 100% utilization of your phosphate fertilizer. It's just not going to happen chemically or physically. So in adjusting a soil pH, for goodness sake, base it on a soil test. Our little deal that's on the web page says soil test, don't guess. Just because your neighbor limed a garden doesn't necessarily mean that you need to lime your garden. Test it and find out. All right, lime, you can get a lime or sulfur requirement on your soil test if for the crops you've indicated there's a need for lime to raise the soil pH or for sulfur to really drop that soil pH. Lime raises the pH, sulfur reduces the pH, makes it more acidic. There's that old adage, if you overdo it with sulfur and or lime, you can create more problems than you can deal with. Well, if I made the pH too low, golly, I can just lime it back up. You have jacked with the soil chemistry if you get that pH down to 2.9 and you're trying to grow vegetables. You have fouled up. And it's not going to be a case of 1 ton of lime per acre. It may be 20 tons of lime per acre that you need to put out. Just keep that in mind. Again, here's the liming materials: ag lime, calcitic lime, dolomitic lime, hydrated lime, but there's a precautionary deal there. And to lower the pH, elemental sulfur or aluminum sulfate and caution. And if you call your county agent and he tells you to use ammonium sulfate and you go down to the feed store, seed store, whatever, and buy aluminum sulfate, you have fouled up. Soil testing. The purpose of soil testing is to give you as our clients, to provide you with enough information to make a wise choice regarding soil amendments or fertilizer additions to your soil for whatever you're growing. It measures the plant available portion of the nutrients in the soil, not the total amount. A routine soil test at LSU gives you a soil texture for some of the samples. Now, the mail-in samples that you mail into the lab in the little sample box will not have a texture on it. A texture does get run by the lab, but it's just not reported on that form. But it will give you the pH, calcium, magnesium, phosphorus, potassium, sulfur, sodium, everything that's listed for $10. $10 is a good investment to know where you're starting from. There is a test question that talks about nitrogen. Here's the nitrogen cycle. It's a rough-looking slide, but what is it? It's a cycle. You have nitrogen in one form that goes to another form that goes to another form, and some of it, as nitrogen gas, gets evolved from that cycle. There is no reliable soil test for nitrogen availability in the Mid-South. We have some researchers in Arkansas that are working on it. We have some researchers here in Louisiana over at the Rice Research Station that are working on it. Because you can, in our lab, you can request total nitrogen if you want to, but it's not going to tell you a blame thing, because total nitrogen encompasses all of the nitrogen in that soil. That's in the organic form, that's in the ammonium form, and that's in the nitrate form. Does that tell you total? Does that give you any idea about what is plant available? Nope. So you don't need to spend that $10 to get total nitrogen. Okay, there's many complex transformations in this nitrogen cycle. Interlocking succession of largely biochemical reactions. Total nitrogen encompasses all the phases of nitrogen, it's just like taking a picture of a greyhound rat, a dog when they're running that rabbit. You get a picture right now, and you get a picture tonight, and a picture on down the line, but that doesn't tell you at the end what the result's going to be, does it? No. Philosophy of soil test recommendations, basically, we're going to base them on soil test results for samples that are taken about every 3 years. We're going to recommend that the lower testing soils be built up to a higher test level by adding fertilizers. We're going to apply a maintenance type fertilizer containing plant nutrients to keep those higher testing soils up there. We want to keep our productivity high, like our vegetables and our high value crops. But we have made some changes in the last 3 years, and some of the recommendations we're calling for exceedingly high rates of phosphate and potash, particularly even when the soil test recommendations were very high, which was uncalled for. So, you do not apply specific nutrients to soils that are testing very high. If it says very high, that means we don't need any more at all, because the soil can supply 100% of the plant's needs. If it's very high, we can take care of 100% of the plant's needs, plus leave some in the soil for use the next year. Using your soil test results, you need to understand the information that's on the soil test result sheet. Yes, if you've never done this, it will be like reading Greek, I can assure you. But it's not a problem, because you have on that soil test sheet at the bottom, your county agent gets a copy, and here's their telephone number. And you can dig into their brain. Our agents are well trained and can handle these situations. You get a soil test results and ratings. That's on your soil test results sheet. You get a raw value for a nutrient, and then you get whether it's high, medium, or low, or very high, whatever, for whatever crop you have listed. You get fertilizer and lime recommendations on your soil test results sheet. Then 2 or 3 days after you received your materials, if you have an email, as soon as the sample is completed with all the analyses in the lab, they'll send you an email with your soil test result sheet attached. We cannot at this time transmit along with that this soil test information sheet. But wait a couple of days, you'll get a soil test information sheet and read through that thing, because there's some very good information in there concerning what crops you're planting. Soil pH indicates the level of active acidity or alkalinity in a soil. Maintaining a pH between 5.7 and 6.5 will generally provide a favorable environment for most of our plants, except the real acid-loving plants, like the blueberries, some of the gardenias, things like that, azaleas. All right, lime recommendations are made to correct problems with soil acidity. The soil is too acid, it has a bunch of hydrogen, manganese, or aluminum that's in there interfering with the plant's ability to pick up other nutrients. The recommendations are based on the soil pH, the soil texture, and the crop you're going to be growing. 2 types of liming materials that we recommend, the calcitic lime or the dolomitic lime. Look at your calcium and magnesium levels on your soil test and how it's rated. If they're medium or lower, you need to add, if it's the magnesium particularly, if the magnesium is medium or lower, you need to add dolomitic lime if you're needing to lime. And that's what's on there. Soil test ratings. This is a part that a lot of folks don't understand, so I'll explain it. All labs rate their soils and the nutrient contents on some similar system like this. All right, very low. That tells you that less than 50% of the crop potential can be had if you add no fertilizer. At this point, your crops are screaming at you. We need some fertilizer, kind of like Mardi Gras. Throw me something, mister. Then you get down to low. We're up the notch a little bit. 50 to 75% of the crop potential and or that aesthetic look you're looking for. If you don't fertilize, you need to fertilize. If it says medium, 75 to perhaps 95% of the crop potential can be had if you do not fertilize. At medium, we call this a maintenance type fertilizer program. If you get to high, no fertilizers needed. The soil can supply everything the plant needs. And if you're at very high, no fertilizers needed, no need to fleece your pocketbook. You could get yourself into problems by overdoing a fertilization program and having real high phosphorus that may cause zinc, iron, or manganese deficiencies and or some environmental problems. So if you fertilize too heavily for too long a period of time, you can also have fertilizer salts build up in your soil, and that can cause you some major issues. You use the nitrogen that's recommended on the sheet, and it's all been researched out basically for all these different vegetable type crops. Also on the home gardens, we have 3 groups of plants we have grouped the vegetables into: group 1, group 2, and group 3. And that particular soil test information sheet is G808. And it kind of explains when you need to put your fertilizers out. Like for the group 1 plants, which are sweet corn, tomatoes, strawberries, and there's one more in there. It says a total amount. The amount that you get on that sheet is going to be a total amount. If it said 5.25 pounds of ammonium sulfate and 3-point-something pounds of urea and whatever below that, that's for the total year. But you read that information sheet, G808, and it tells you for the group 1 plants, use 2/3 to 3/4 or 1/2 to 2/3 of the nitrogen up front prior to planting, mix that into the soil, and then reserve that other third or so for side dressing in the normal process of the year as the plant develops. For tomatoes, after first fruit set, you'd want to put some nitrogen down, and then between that 3rd and 4th fruit set, put some more nitrogen down. That keeps the plant growing, and that keeps the nitrogen available to that plant. All of our soil tests now are extracted with one solution for a routine, the Malic 3. All the test results in parts per million. Some of the other labs, commercial labs, and even some of the university labs in the southeast will report pounds per acre. If you do happen to do that, you can take pounds per acre and divide it by 2, and that gives you parts per million. What it measures just for phosphorus, just as it does for calcium, magnesium, the other nutrients, a measure of the relative availability of those nutrients, not a quantity that would be a total in that soil. You would have to digest that soil with hydrofluoric acid and use a Teflon beaker. And hydrofluoric acid is very, very harsh. The recommendations on phosphorus and some of the other nutrients are given as ounces per bush in some cases. Most of those we have changed over to ounces or pounds per 100 square feet, 1,000 square feet. Much easier. Organic matter. Think about this. If you run our organic matter test, it's expressed as a percentage. There are no rating scales in there. It measures that resistant state of organic matter that's in the soil, that humic and fulvic acid. Consider this. An acre of soil measured to a depth of 6 2/3 inches, which we call an acre furrow slice of soil, weighs about 2 million pounds on a dry weight basis for sands through clays. If you averaged them out, 2 million pounds, meaning that 1% organic matter in that soil would weigh about 20,000 pounds. And since, on average, we consider organic residues composting down to 1/10 of the percent that it was, you would have to have at least 200,000 pounds or 100 tons of dry material applied to the soil to add 1% stable organic matter under favorable conditions and time. Rome wasn't built in a day, and organic matter is not going to be either. We'll insinuate, and some actually put it on their labels, that you only need to use 300 to 500 pounds of the pelletized lime to be equivalent to a ton of lime per acre. Again, physically and chemically that's not possible. A ton of lime is a ton of lime. Till you get to the hydrated limes and the quick limes. And they have a lot more calcium carbonate equivalents in them. So if you're going to use quick lime, you're going to use about 1/3 less liming type material, but that pH that you get in that soil is going to be short-lived, probably for not more than a year, year and a half, 2 years at most. Whereas agricultural grade limestone is going to give you a long-lasting effect of that lime because you have fines, mediums, and a little bit larger size particles. The fines go to work immediately when you incorporate them into the soil. If you're going to leave your lime on top of the soil, as you would have to in a lawn situation, then it's going to take about 2 years for that liming reaction to get down about 1 inch. Really. So don't let your pH go too far to the left, being acid, before you try to correct it, because it's going to take several years for that liming reaction to get down to 1 inch. And that's a very important consideration. I think this is on the test. 1 acre is 43,560 square feet. That's something you have to know. You need to know it anyway. And then anything at a rate of about 45 pounds per 1,000 square feet is equivalent to 1 ton per acre. Length times width gives you your square footage. If you get a round pot, I had to go back and look up the formula. Pi r squared. It was back there somewhere, but it wasn't up close. So, on the lime, we used to have to figure it out. Now on the soil test result sheet, if it says 2.29 pounds per 100 square feet, that's what you need to put. You don't need to put 3 pounds, 2.29. There are additional soil tests at the Soil Test and Plant Analysis Lab. That's what that acronym up there stands for. Organic matter, $4 per sample. Micronutrient test, zinc, iron, manganese, and copper. You don't need that one. This soil test was put into effect by a group of scientists in Colorado back in or about 1970, early 70s, real early 70s, to look at the availability, particularly of zinc, iron, manganese, and copper in high pH soils. You do not need that here in Louisiana. You're going to get zinc and you're going to get copper on your soil test. And then we're going to look at it and we're going to see, based on the pH and the plants you're growing, whether you might need those too. Heavy metal test. This one is not applicable anymore. We're going to take this off of the internet because so many folks from the New Orleans metro area are still concerned about the lead, arsenic, and things like that that are in the soil. A lot of that is native in those soils. Arsenic, cadmium, lead, and zinc. You get zinc. This test was originally set up for rice farmers because cotton used to be grown from Claiborne Parish all the way down to a little spot they call Pecan Island. And right off of Pecan Island, and I'm saying in 74, 75, the remnants of old cotton gin were still on solid terra firma, were on solid land. I was down there not too long ago, and those remnants are now out in the marsh because of subsidence. That's not a test that we check for environmental issues. The arsenic was because rice cannot stand arsenic, it cannot tolerate it, and then zinc from the standpoint of was it going to be zinc deficient. You can get aluminum, boron, sulfur, soluble salts, extractable oil, that one's coming off of there, for $5. Individual separate analyses. Soluble salts is one thing that we do run that particularly where folks have over-fertilized their gardens or fields even. We do have a flood test. This is generally used by those folks down in the New Orleans metro area that are building levees, the contractors. And we interpret these ourselves. We're looking primarily at electrical conductivity, which we convert to salts. We look at an SAR, which is a sodium adsorption ratio. Then we look at the concentrations of chloride, sodium, and also sulfur as a sidelight. We have a soilless routine for potting mixes. This is a good test. It gives you an idea of where you are if you have soilless type media. Even up to, as I best remember, a little bit less than 20% soil in a media, you could use this soilless deal. If you're looking for environmental assessment issues for heavy metals here, I'm going to direct you to the W.A. Caligari lab, which is right on down, down at Ben-Hur, down at the research. That's another one of our analytical labs in the LSU system. They used to offer a sample for totals for $14 just here recently. They have upped that cost, and I have to get that and change this slide. Fertilizer produces results that are considered to be desirable. That's what you're looking for. Applied to obtain those desirable properties or results that you're looking for whenever you expect to get that plant response, and that's where those ratings or interpretations come in, the very low, low, medium, high, very high.